Hey, it's Sarah and Sarah here to talk about Chapter 18, Pathogens of the Cardiovascular and Lymphatic System. So the first one is our good old friend Staphylococcus aureus, which is a normal resident of the skin but has a knack for getting in places where it's not supposed to and causing infection. So within the cardiovascular system, it can get into the blood, cause septicemia, can also result in endocarditis, inflammation of the heart. Streptococcus pyogenes can cause disease of the heart. Rheumatic fever is the sequelae of a strep infection. So if you get strep throat and you don't treat it, or scarlet fever, which is another manifestation of strep infection. Strep can get into the blood and travel to the heart. And then the body basically mistakes, it gets confused between strep and some of the proteins on your heart, and it starts generating cross-reactive antibodies that start actually attacking the heart. So strep can induce this sort of almost auto-inflammation of the heart. That's called rheumatic fever. Streptococcus pneumoniae, which is the pneumococcus and causative agent of pneumonia. I keep forgetting this is a gram-positive bacteria. The other two were also gram-positive bacteria, strep and staph. So strep pneumoniae, we've talked about it causing meningitis. It obviously causes pneumonia. It's in the name, but it also can lead to acute endocarditis. Yersinia pestis is the causative agent of the plague, the black plague, or just sometimes referred to as the plague. It's a gram-negative bacteria. Actually looks a little bit like a safety pin. I kind of tried to demonstrate that here, but not much of an artist. So Yersinia pestis, think pestis, like pests, rats, and fleas on rats were the transmitters of the plague. So a pest, think of that, Yersinia pestis. Francisella tularensis, not a very common pathogen. It is a zoonosis, a zoonotic bacteria that comes from rabbits. So if you come into contact with an infected rabbit, it's actually very contagious, but typically humans are not in contact with infectious rabbits all that often. So Francisella tularensis, also known as rabbit fever or tularemia. Borrelia burgdorferi is becoming more and more of a problem in the North Country. This is the causative agent of Lyme disease. It's a gram-negative bacteria, and it causes Lyme disease. It's transmitted by ticks, deer ticks more specifically, and causes, well, I'll get into it more in class and lecture, but it's a disease of the lymphatic system, and it's really a systemic infection, and it can it's really important to treat it early. If you don't, it can go into these late stage symptoms that are really hard to treat, and it's hard to kill the bacteria after it's already established itself in the body. So it can cause chronic infections, and that's where it's really problematic. Brucella is really more a disease that affects livestock than humans. It causes brucellosis. So the species names listed are Brucella abortus and Brucella suis. So these are diseases that are really bad in cattle, can cause miscarriage in cattle, and can devastate livestock. And it's even actually under research as a potential bioterrorism agent in order to sort of devastate the country's economy by taking out all its cattle. Just sort of a different way of going about things. Bartonella hensleyi, I think I said that right, is a gram-negative bacteria that causes cat scratch disease, which again, not terribly common. It's usually from younger cats, not older cats, but it's a bacteria that they can carry, and if they scratch you and it gets into the wound, it can cause cat scratch disease. Epstein-Barr virus, next on my list. Notice I skipped over a couple. If you're watching the videos, you're noticing ones that I think are less important and will not show up on the quiz. So focus on the ones in the video. Epstein-Barr virus, also known, causes the disease that's also known as mono. and or mononucleosis, infectious mononucleosis, kissing disease, whatever you want to call it. Most people get Epstein-Barr. Like 99% of people have probably had this virus. If you get it when you're young, it just causes like a cold. But if you get it in your teenage or early adult years, you tend to get hit really hard. You get a lot of fatigue, a lot of inflammation of the spleen. It infects the lymphatics. So it depends on the age that you get infected, what sort of symptomatology you have. Now, of course, there's always outliers. There are kids who get full-on mono, and there's adults who probably get the virus and don't even know they got it. So, but Epstein-Barr virus is the virus that causes mono. It's also called EBV for short, most commonly. Yellow fever virus causes, guess what? Yellow fever. Not terribly common anymore, but devastated the U.S. in like the colonial days. Dengue. Oh, how did you get here? Bacillus anthracis. You belong at the top of the list. Anyway, we're back to bacteria. Bacillus anthracis is the gram-positive bacteria in this chapter, and it causes anthrax. Remember, anthrax can cause cutaneous disease. We'll also see it can cause respiratory disease, but it can also cause sepsis or systemic anthrax. So that's what it's doing in this chapter in the cardiovascular system. Back to viruses after our little boondoggle there. Dengue fever is caused by dengue fever virus. Dengue fever is very prominent in tropical regions of the world. It's transmitted by mosquitoes. Not a fun infection to have. You feel like you've been hit by a train. And also, if you get infected more than once, your risk of mortality actually goes up. You sort of have the opposite of immunity, so you become almost more immune sensitive to it, that you have more inflammation the second time around. So we need a vaccine for that one. Ebola and Marburg viruses often make the news when there's outbreaks of them. They have pretty high mortality rates, but another reason for that is they are endemic to Africa, certain parts of Africa where there's really no healthcare infrastructure. So these outbreaks can be very difficult to contain, and they spread, and they're difficult to treat because there's really not good healthcare facilities. So if Ebola was in the U.S., it probably wouldn't be as dangerous as it is in Africa, just because of differences in healthcare structure. That aside, the reason it's in this chapter is because it's a hemorrhagic fever. It causes hemorrhagic fever. So there's a fever, but also there's a lot of hemorrhaging or bleeding. So the blood vessels basically become more like porous, and you can die from internal bleeding. You can also bleed out of lots of orifices, lots of bleeding. Hemorrhagic. HIV, human immunodeficiency virus. There's actually two, HIV-1 and HIV-2. And they cause AIDS, acquired immunodeficiency syndrome. So these are viruses that infect white blood cells. T cells in particular are their favorite. And so after a while, they start to devastate your T cell populations. When your T cell populations have been sufficiently depleted, that is when somebody is said to have AIDS. So there's antiretrovirals that one can take. HIV is a retrovirus. And we have some actually really good retroviral therapies, and so we're at a point now where people can just take retroviral drugs and kind of live for a very, very long time, live out the rest of their life, HIV positive, but without developing AIDS. So AIDS is the problem, and that happens when HIV virus decimates your white blood cells, in particular the T cells, and then leaves you with virtually no immune system. On to the protozoa, Plasmodium falciparum. HIV and Plasmodium are two of the biggest killers on the planet. They are really important pathogens. Plasmodium causes malaria, and there's actually several subspecies. There's Plasmodium falciparum, which is on this card. There's also Plasmodium vivax, and some other Plasmodium subspecies, but the one that causes the most disease is Plasmodium falciparum. It's a protozoan. It's not an amoeba, even though I've kind of drawn an amoeba on this card. It's not an amoeba, but it is transmitted by mosquitoes, a specific species of mosquito, and so Plasmodia only exists in regions of the world where that mosquito exists. And we watched some interesting TED Talks earlier this semester about potentially manipulating mosquito genetics or mosquito microbiomes so that you can make mosquitoes that are resistant to malaria. So that would be a great way to stop malaria transmission. Hard to make a vaccine for it, and we'll talk about why in class. Plasmodia is a protozoan. It causes malaria. Lastly is Trypanosoma cruzi, which is a protozoan, and it causes a disease called Chagas disease, which is also sometimes called the American sleeping sickness. There's another type of trypanosome that causes African sleeping sickness, but they're different. So Trypanosoma cruzi is causes a disease called Chagas disease. That we'll talk about in lecture. The end. Bye.